Okay, we'll begin, I think. Welcome to our class, and we'll continue with what we have learned in the last class. That means yesterday. Oh yeah. Before forgetting one thing, I'll say Monday. That means the Monday, the 6th April. We don't have class this day. It's it's like holiday. So after this class, we'll have class on Wednesday, the 8th April. Okay, is it clear for everyone? Hi, Hosan, Roy, Jahi. Yeah. You can have a break, have 3 days of weekend. So it's a good thing for you, perhaps. We'll continue with our 7th chapter, design and implementation. In the last class, we have talked about the 5 activities in the object-oriented design process. Yeah, I think it may be the 3rd time or the 1st time that I ask this question. Which 5, can you list the 5 activities in the object-oriented design process? Yeah, last time it was Ramnak who has answered for all these 5 activities. 5 activities in the object-oriented design process. Can you list them? Kaya design the system architecture. Yeah, it's one of the 5 activities. Design models. Develop design models. Others. It's a way to see your presence. Yeah. Perhaps we can ask I'll ask someone to see if are with us. Saddam, you are mystery this semester. Specify object interfaces. Yeah, Ramnak, you are right. Any other volunteers? Else, I want to see if Saddam is always with us. Saddam, can you write here? Sajid has answered for the identify the principal objects in the system. Yeah, very good. So we have already 4 activities. We have only one left activity. So Saddam, can you tell us the resting one? As we have 5 activities here, your classmates have listed 4 of them. You see design, system, architecture, develop design models, specify object interfaces, identify the principal objects in the system. And the 5th one, what is the 5th activity? Oh, Saji, you helping understand and define the context and the external system. Yeah. Precisely is to understand and define the context and the external interactions with the system. Yeah, it's like define the context and modes of use of the system. These are 5 activities involved in the object-oriented design process. These 5 activities composed. They have composed the 5 subsection of object-oriented design using the UML. Then we have introduced we have introduced 3 proposals about how to identify object classes in object-oriented systems. And this question may be a little difficult for you, perhaps, I'm not sure. 3 proposals about how to identify object classes in object-oriented system. Do you remember the 3 proposals about how to identify object classes in object-oriented system? Yeah, we have talked about this, and we had an example yesterday. Roy has answered for the question. From an example, we can identify the object classes from a description. So how can we describe the 3 proposals about how to identify object classes in object-oriented system? Do you have some ideas? Nouns, Kaya, you get something. You are getting some ideas. Nouns, verbs. We can correct. In general, we can correct. Use a grammatical analysis of a natural language. Description of the system. So the first proposal, as said by Kaya, use a grammatical articles. What does it mean, Hosan? Use a grammatical analysis of a natural language description. Yeah, Kaya has answered for a second one too. Use a scenario-based analysis. Yeah. And we have the third one. Yeah, Saji also has given this proposal, user scenario-based analysis. So we have only one left. That's to use tangible entities in the application domain. Yeah. This one we have in the. Have I sent the slide for you? This chapter, have I sent it to you? If not, tell me if I didn't send this slide. No. Okay. So I will send it to you after class or during the break. Yeah, you see here we have these three approaches. Use a grammatical approach based on a natural language description of the system, base the identification on tangible things in the application domain, and use a scenario-based analysis. These are three approaches to identify object classes in object-oriented class. And later we have also talked about design models, which is the fourth activity of the object-oriented design process. For designing models, we have talked about two kinds of design models. Do you remember two kinds of design models? Yeah, thank you, Ramnak. Yeah, it's static and dynamic. Static models we can also create structural models to describe the static structure of the system using object classes and their relationships. Then we have the dynamic models to describe the dynamic structure of the system and show the interactions between the system objects. And after this, we have talked about three models that are particularly useful for to use case and architectural models. Yeah, that means we have talked about three models in detail. Three useful models. Okay. First, it's better to write it like this. Three useful models for adding detail to use case and architectural models. Do you remember these three useful models for adding detail to use case and architectural models? Yeah, subsystem models, as said by Kaya and Ramnak. Yeah, sequence models, as said by Ramnak. And last model. The last one, can you remember it? Yeah, okay. Notice interface in specification. No, I'm sorry, Kaya. The last model is to show how individual objects change their state. Yeah. As said by Ramnaka and Roy state machine model. So we have these three kinds of models to help us to have more detail about the use case and architectural models. Subsystem models to show logical grouping of objects into coherent subsystems. Sequence models to show the sequence of object interactions. And state machine model to show how individual objects change their state in response to events. These are three models. Yeah, we had some examples of these three models, and yeah, we had always taken the example of weather station system. And yeah, the last part that we had in the last class is about, I think, design patterns. Yeah, we have talked about design patterns, and we say there are four essential elements of design patterns. Do you remember the four essential elements of design patterns? A meaningful pattern identifier. Yeah. Problem description. Very good. Yeah. And another two. Consequence. Yeah. A statement of the consequences. Yeah. It's you're right, Roy. And Ramnak say name problem. Yeah, here name is what Kaya had said, a meaningful pattern identifier, and problem description. Yeah, you are right, Ramnak. And then we have, yeah, Sajib to complement with the solution description. Yeah, these are four elements, four essential elements of design patterns. They are here. We have a name that is a meaningful pattern identifier. We have a problem description that explains when the pattern may be applied. We have a solution description of the part of the design solution, their relationships and their responsibilities. Also, we have a statement of the consequences. That means the results and the trade-offs. With this, we can, that means how to apply the Python. And this can help, this statement of the consequences can help designers understand whether or not a Python can be used in a particular situation. Okay, these are four essential elements of design Pythons. Yeah. Later we had some examples to explain these design Pythons. Now we'll continue. Yeah, I think we had yeah, we had talked about this in the last class. To use Pythons in your design, we need to recognize that any design problem we are facing may have an associated Python that can be applied. You see here we have different Pythons to apply when we have different problems. Now we'll continue with the next section, which is the implementation issues. For the implementation issues, as we know that software engineering includes all of the activities involved in software development, from the initial requirements of the system through to maintenance and management of the deployed system. Among these activities, we have a critical stage of this process, which is the system implementation. With this system implementation, we create an executable version of the software. Implementation may involve developing programs in high or low-level programming language, or tailoring and adapting generic off-the-shelf systems to meet the specific requirements of an organization. Yeah, as we have already some programming experience. Normally, we have some, we can understand some programming principles. Here, our objective is to offer a language-independent approach. So, we will not focus on programming. Instead, although programming is very important, but we will focus on other implementation issues that are often not covered in programming texts and that are independent from a programming language. These implementation issues include reuse, configuration management, and host target development. Here we have some introductions to these three implementation issues. The first one, reuse. Most modern software is constructed by reusing existing components or systems. When we are developing software, we should make as much use as possible of existing code. And reuse, I think we have already talked about it before. In many cases, it's better if we can reuse some functionality or some interface of a program, of our system. The second implementation issue is the configuration management. During the development process, we have to keep track of the many different versions of each software component in our configuration management system. Here, as we know, during the development process, Many different versions of each software component are created. So if we don't keep track of these versions in a configuration management system, we are liable to include the wrong versions of these components in our system. And the third implementation issue is the host target development. Production software does not usually execute on the same computer as the software development environment. That means we will develop the system on one computer, that means the host system, and maybe we will execute it on another or separate computer. We call it the target system. In fact, sometimes the host and target systems are of the same type, but often most of the situation, mostly they are completely different. So we may have this problem, this implementation issue of host target development. Now we'll talk about these three implementation issues in detail. For the first one, reuse. The history is that from the 1960s to the 1990s, most new software was developed from scratch by writing all code in a high-level programming language. And the only significant reuse of software was the reuse of functions and objects in programming language libraries. However, costs and schedule pressure means that this approach became increasingly unviable, especially for commercial and internet-based systems. As we know, if we have to develop the whole system by ourselves without reusing, we may take much longer time, and that's why it will be much more expensive. That's why here we say cost and schedule pressure causes the unviability of this approach, especially for commercial and internet-based systems, as these kinds of systems, they update very quickly. So, consequently, an approach to development based around the reuse of existing software emerged and is now generally used for business and scientific software, and increasingly in embedded systems engineering. So you see, these are the backgrounds of reuse, the history of reuse. In fact, software reuse is possible at a number of different levels. The first level is the abstraction level. At this level, we don't reuse software directly, but use knowledge of successful abstractions in the design of our software. In fact, with this level, design patterns and architectural patterns, there are ways of representing abstract knowledge for reuse. The second level is the object level. At this level, we directly reuse objects from a library rather than writing the code ourselves. By this level, to implement this type of reuse, we have to find appropriate libraries and discover if the objects and methods offer the functionality that we need. For example, if we need to process mail messages in a Java program, we may use objects and methods from our Java mail library. Yeah, you see, that's why we say reuse has different levels. And we have the third level, which is the component level. Components are collections of objects and object classes that we reuse in application systems. In fact, here these collections operate together to provide related functions and services. We often have to adapt and extend the component by adding some code of our own code. An example of component level reuse is where we build our user interface using a framework. This is a set of general object classes that implement event handling, display management, etc. And we can add connections to the data to be displayed and write code to define specific display details, such as screen layout and colors. And this is for the component level. We have the fourth level of software reuse, which is the system level. At this level, we reuse entire application systems. This usually involves some kind of configuration of these systems. And this may be finished by adding and modifying code. Yeah, if we are reusing our software product line, we will add or modify the code. We may also use the system's own configuration interface. Yeah, nowadays most commercial systems, they are built in this way. Then we adapt the system and reuse it. Also, sometimes this approach may involve reusing several different systems and integrating these different systems together to create a new system. We can call it an integrated system. So you see, reuse is rather common in developing systems. We have different levels of reusing, and we need to determine the level according to different situations. By reusing existing software, we can develop new systems more quickly and with fewer development risks and also lower costs. Well, as we know, when we reuse our software, the software has already been tested in other applications. Normally, it should be more reliable than new software. So you see how efficient it will be if we have the if we use this software reuse. However, there are some costs associated with reuse. The first one is the cost of the time spent in looking for software to reuse and assessing whether or not it meets our needs. When we want to reuse our software, we may have to test the software to make sure that it will work in our environment, especially if the software is different from its development environment. Yeah, where applicable, the cost of buying the reusable software. For large off-the-shelf systems, these costs can be very high. Yeah. We for some large, yeah. In most cases, especially for some large off-the-shelf systems, we may not give us the authority to reuse the system freely. So we need to pay for it too. The third course are the costs of adapting and configuring the reusable software components or systems to reflect the requirements of the system that we are developing. Yeah. You see here, when we want to reuse software components, as we have mentioned before, we may have to adapt it and configure it. So we have some costs related to these things. Another cost related to reuse is the cost of integrating reusable software elements with each other. If we are using software from different sources and with the new code that we have developed. Yeah, for the when we talked about the different levels of software reuse, we have said that sometimes we need to combine different systems to integrate them to create a new one. Here, integrating reusable software from different providers can be difficult and expensive because the providers may make conflicting assumptions about how their respective software will be reused. So you see, we may even the reuse of software is an efficient way. It may also have different costs. So how to reuse existing knowledge and software should be the first thing we need to consider. We should think about it when we start a software development project, and we should consider the possibilities of reuse before designing the software in detail. As we may wish to adapt our design to reuse existing software assets. As what we have discussed in the second chapter, in a reuse-oriented development process, we search for reusable elements, and then we modify our requirements and design to make best use of it. For a large number of application systems, software engineering really means software reuse. Yeah, we have talked about it in the second chapter, if you remember. So, yeah, now, before continuing to to the next part, we'll we'll have a revision here. Do you remember what we have talked about, the three aspects of implementation that are particularly important to software engineering? Yeah, thank you, Kaya. Yeah, you are right. Reuse and others. And the other two aspects. Configuration management. Yeah. Perfect. Thank you, Kaya, and another host. Yeah. Okay. Yeah. Good job. Thank you very much, Kaya. These three aspects of implementation that are particularly important to software engineering. Yeah. And we have already finished the introduction of reuse. We have talked about the four levels of software reuse: the abstraction level, the object level, the component level, and the system level. We have also talked about the codes associated with the reuse. Yeah, we have talked about four parts of codes. This is for the reuse, and later we'll talk about the other two aspects of implementation, configuration management and host target development after the break. Now I will note for your attendance. I have seen Amin, Faso, Kamruzama, Kaya. Jahi, Shibli, Malala, Hosan Ramnak, Hosan Ramnak, Saji Roy, and Saddam. So as yesterday, we have two absence, Atman and Ken.